Okay, so we're going to talk today about the intro to systems of equations. So we have intro to systems of equations. So before we even learn how to solve a system, we're going to learn just the basics of the system. Let me see if I can get this a little bit brighter. Okay, so when you're looking at a system, if we had an equation from last try, and we had a line zipping through here, so you should be able to graph a line, putting it in slope-intercept form. Open and close the door. Thank you. So what you're going to be noticing is all of these are actually solutions to the system. So every point on this line is a solution to this linear equation or this linear function. What changes is now we're going to have another line zipping through there. So then on this green line, all of these points that form that line are solutions to that linear equation. What you are looking for is the one point that they both have in common. Okay? So if I have a system, I have a line zipping through here, and another line zipping through here, where they intersect, this has exactly one solution. And that solution is going to be whatever ordered pair that actually is. If you have this scenario, and last trimester we talked about parallel lines. So parallel lines would never intersect. Because parallel lines will never intersect, there's never going to be a point that they both have in common. So this would be none or no solutions. And it's because the lines are parallel. Okay, then there's only one other scenario that we have, and that is if I graph this green line, and then I graph another line, but it's right on top of it. These are called coinciding lines, and because every point on the green is also on every point of the orange, these would have infinitely many solutions. Okay, so let's kind of recap that. If the lines intersect, they have one solution. The lines are parallel, they have no solutions, and if they are on top of each other or coinciding, basically the same line, then they have infinitely many solutions. So that's what we do by looking at a graph. You should also be able to tell how many solutions by looking at the system itself. So this is by looking at an actual system. We'll have this as example 1. So if I give you y equals 3x plus 5 and y equals 3x plus 5, and I ask you to graph those, aren't these going to be the same line? The slopes are the same. The y-intercepts are the same. So same slopes, same y-intercepts. Therefore, they're going to be on top of each other, which means there's infinitely many solutions. Example 2. Let's do... Okay, so here's this system, meaning you have 2 or more equations working on the same problem. Here, the slopes are the same, but here the y-intercepts are different. So if we have the same slopes, but they cross at different points, that means the lines are going to be parallel. So that would mean that these are no solution because the lines are parallel. And we know that because they have the same slope. Same slope and different y-intercept. The third and final example oopsie, ignore that. Example 3, the third and final example. Would be something like this. Clearly, these are different slopes. And we don't need to go anything else from there. Once you realize that the slopes are completely different, that means the lines are going to intersect. Therefore, you're going to have one solution. And just kind of refreshing your memory a little bit, when you are graphing or when you are determining this, get your equations in slope-intercept form. So y equals mx plus b. It's going to be the easiest way to look at your slope and look at your y-intercepts at the same time.